Have you ever wondered why there are rainbows? Did you ever see a prism work and wonder why a prism seems to create rainbows? Well, in this lesson you'll learn about prisms, how they work, why they work, and what applications they may have to everyday phenomena. A prism is an object made of a transparent material like glass or plastic that has at least two flat surfaces that form an acute angle less than 90 degrees. White light is comprised of all the colors of the rainbow. When white light is passed through a prism, the colors of the rainbow emerge from the prism much like in the figure here. We'll learn more about why a prism spreads white light out into the colors of the rainbow. Have you ever noticed that people standing in a pool always look shorter than they really are? Or that a spoon in a glass of water seems to be bent? The reason why these phenomena occur is because of the concept of refraction, which is simply the bending of a light wave. In order to further understand what refraction is and why it occurs, we need to look at what happens to light when it goes from one medium to another, like from air to water or a vacuum to air. The speed of light in a vacuum is denoted by the letter c and has a value of 300 million meters per second. When light goes from a vacuum to another medium, light slows down. How much it slows down is dependent on something called the index of refraction, which is denoted by the letter n. The index of refraction is a property of a material or medium. When light goes into a denser medium, it slows down more. The denser the material, the slower the light will travel through that medium. The speed of light in a material, denoted by v, changes according to the following formula. V sub n equals c over n equals 3 times 10 to the 8th meters per second over n. The table here is a sampling of different materials and their corresponding index of refraction. Based on the index of refraction, the speed of light is fastest in a vacuum and slowest in a diamond. The reason why light slows down is because it bends as it goes from one medium to another. The figure here illustrates an incident light beam entering water, red light ray, and refracting as it goes from air to water, blue light ray. The law that governs the bending of light as it goes from one medium to another is called Snell's law and is given by the equation here. All of the angles in Snell's law are measured from the normal, the imaginary dashed vertical line shown here. When light goes from a medium with a smaller index of refraction to one with a larger index of refraction, the angle gets smaller. It bends toward the normal. An example would be when light goes from air to water, and another example would be from air to glass. When light goes from a medium with a larger index of refraction to a medium with a smaller index of refraction, like from water to air, the angle gets larger or bends away from the normal. Refraction explains why light bends in a prism, but does it also explain why the colors of the rainbow emerge from a prism? Yes, it does. But in order to explain why the colors emerge, we need to look at two more properties of light waves. Every wave has two important properties, a wavelength and a frequency. The wavelength is the distance over which the shape of a wave repeats. The figure here illustrates the concept of a wavelength. The frequency of a wave is defined as the number of oscillations or complete wavelengths per second. The speed of any wave, including light waves, can be written as a product of wavelength and frequency. When a light wave goes from one medium to another, the frequency of the wave remains unchanged. However, the wavelength changes, causing the wave to change speed as it moves from one medium to another. The table here shows the wavelengths of visible light. Since white light is made up of all the colors listed in the table, when white light enters a prism and the light bends, the white light spreads out into different colors of the rainbow. This process is called dispersion. The larger wavelengths have a greater speed, red and orange, and the smaller wavelengths have a lower speed, blue and violet. Since they have different speeds through the prism, they bend by different amounts as they exit the prism. The most spectacular example of dispersion is the rainbow. There are two major things that need to be present for a rainbow to happen: drops of rain and sunlight. The drops of rain act like tiny little prisms, and when the white light from the sun encounters the rain droplets, the white light spreads into the colors of the rainbow. There are many little droplets in the sky, causing the effect to be magnified into what we see as the rainbow. White light is the combination of all the colors of the visible spectrum of light, which have different wavelengths. A prism is a clear, triangular device made up of plastic or glass or any transparent material. When white light goes through a prism, the light bends due to the phenomenon called refraction. Refraction is the process of bending light as light goes from one medium, like air, to another medium, like water or glass. The bending happens because light changes speed as it goes from one medium to another. Waves have a wavelength, the distance over which the shape of a wave repeats, and frequency, the number of oscillations or complete wavelengths per second. And when light refracts, the frequency remains constant, but the wavelength changes. Since white light is made up of a variety of different wavelengths, the light is dispersed through the prism, which separates the light into different wavelengths, or colors. So when white light passes through a prism, a rainbow emerges on the other side.